Hey guys, welcome to Technical's Mentor channel. Today we will discuss the high pass filter technique which we use in this video, which is Blackman technique to remove noise and DC drift from ECG data. We have already discussed different techniques in the previous videos such as triangular. So if you want to see these techniques, please see my previous videos in the playlist. So today our topic is applying Blackman technique to remove noise and DC drift. So we already done some work such as how filter data, what is ECG data, how I load ECG data in the previous videos. So without wasting time, we come to the point. So to check the ECG data using Blackman technique, we create figure and we make a Blackman variable using previous data HN2 and tabs which we already create. So this Blackman uh, function is MATLAB button function. You can see in the MATLAB Blackman return the endpoint symmetric Blackman window in a column vector. So it is built-in MATLAB function we apply to see the ECG data. What will be the result? So we apply this function and transpose the data. Okay, so we created the Blackman data using Blackman technique. Now we check the data using Fourier transform in the frequency response using Blackman window technique. So we have to plot in frequency domain data. So we use Fourier transform. Let's we implement this command and we got a graph. You can see this is ECG data in the frequency response using Blackman technique. We limit the x-axis to see the data in better way. Okay, you can see 0 to 110. Okay, now we label all the axis and title of the graph. Okay, you can see frequency response with black window technique. Y-axis in y-axis there is magnitude which is in dB, and in x-axis there is frequency which is in hertz. So now we check the ECG data using our personal function which we created in the previous video, my fair. So to see the result in our function, we initialize a function which name variable. We initialize a variable which name is filter as who's having one row and column equal to length of Blackman data. Okay, okay. Now we create a loop from 1 to n. N is number of data, and rename it Blackman output using our function. Here we use the ECG data which we created in the previous video in millisecond, and W is a Blackman which we created using Blackman technique. So we create, so we got Blackman output. Here is Blackman output. Okay. Now we check the output which we got after using his function myFair. Okay. This is the data we got using our function. Okay. Now label all the da- data. So after labeling, our data is in time domain with Blackman window technique, where y-axis is amplitude and x-axis is time in millisecond. So we check the data got from Blackman window. We use a Fourier transform. We use Fourier transform because we are making a plot in frequency domain. So it is necessary to use Fourier transform to get result in frequency domain. So we create a Blackman output and frequency response, and we create a graph in frequency range. Okay, so this is our graph in frequency response, and we limit the x-axis to see better result. Okay, you can see this is our frequency response result, and title and x label, y label. So here is our data, how it is moving. Here is ECG data without noise. So today there was a Blackman technique we have discussed. So in the next video we will discuss rectangular technique to remove noise and DC drift. So if you like my videos, please like and subscribe my YouTube channel to see more videos. To see MATLAB videos, please come to my YouTube playlist and you will get extra knowledge. Thank you so much.